Yeah, I normally like to start after the, okay. So just real quick, we're on page 19 of the math packet. This was stuff to do on your own. Yes, I didn't see who was saying, who was talking? Who was pointing this out to me?
I'm Mike Teston.
Okay, hey Mike. Yeah, sorry. It's it's so difficult to tell who's if I'm looking over here, I can't see my screen. Yeah, so as Mike pointed out, section 3 and section 4, they're incorrectly, the instructions are incorrectly labeled. They're just copy and pasted from above. This is to replace the power with a prefix, a metric prefix, and then down here you're just supposed to convert to decimal form. And then the correct answer for number 13 is 0.094 meters. Yeah, because it's centi is times 10 to the minus 2, right? It's 1/100th of a meter. So that's where you get the 0.094 meters. Okay, any more questions about the packet, the self-practice stuff? So good job. Glad to see you guys are working on the packet. And in fact, that's where we're going to start. We're going to start back at the scientific notation, or the unit conversion of mod 3. These again are very generic, easy examples, and it almost walks through too slow because I feel like I'm getting ahead of myself here. It almost walks through the problem so slow, or too slow to be to go over in class. All right, so again, this is basically walking you through the methodology or the thought process, right? If you're given a conversion, what's the thought process you'd be going through to make that conversion? And obviously, right, you're identifying the original measurement here, 750 feet. So we're converting 750 feet to meters. Oops, I need a T. The original unit is feet, and the target unit is meters, right? And then you would look into your conversion tables and you'd find the correct conversion to use. Now, the conversions, was there a question?
No.
The conversions we had given at the start of this were up here. 1 meter is 3.281 feet. Oh, geez, I'm gonna turn my phone off. So we can use that. Now you may be given the reverse conversion, right? 1 foot is whatever meters. And you can also use that as well. It's just a matter of how you set up the proportion or the ratio. All right. So we're going to set this up, and we're going to set it up as, let's see, 750 feet was the original measurement, right? And notice this ratio, this is like taking something and multiplying it by 1, right? In terms of the units, because these are identical to each other, right? This is what's the target unit you want, and what's the original unit. So notice how we have them set up. So the target unit is on top, right? We want feet, and we have meters, right? So how many feet are equivalent to how many meters, right? These two numbers are equal in the sense that the measurement is equal, right? They're not actually, the numbers are not the same, but the measurement is the same, right? This many feet is this many meters. So it really doesn't matter what conversion you're given, right? You could be given that 2 meters is, I don't know, whatever that is, 2 or 6 point, I guess that would be 562 feet, right? You could be given that, and it's the same ratio. So here we're given 3.281 feet is 1 meter. and then you get an answer with your target. So what I'm going to do here is I'm going to write the answer in. Let's see, what is the answer? 220. 228. Oh. 228.58.
I'm sorry. I'm sorry. I have a question.
Yep.
So, it's.
Oh, I'm sorry. I
Please.
screwed this up. I see your question.
Yeah,
I screwed this up. This should be me. Oh my God. I was so feet. I mean, is that your question?
Yeah.
Yeah. This is what happens. I talk and I try to write and
It's a Wednesday, don't worry.
things don't happen properly. All right. So it's 750 feet. This is the target unit is meters. And the unit we have in the original conversion is feet. So this is what I'm saying. It's almost too slow. This is like, have you ever tried riding a bike and you start thinking about it? You're like, oh, I gotta think about it. Or try to do something and you start thinking about what this is like that, right? If you think too much about it, you make mistakes. All right, so 228.58 meters. I'm gonna look at this from the standpoint of, let's rewrite this. Here we're gonna have 750 feet times 1 meter. So I'm going to put all the units in here. I'm going to have 750 feet times a meter, right? These are the units. And then I'm going to have underneath 3.281 feet. And I want you to notice, right, you have feet times meters divided by feet, right? Well, the feet are the ones that cancel. So we're left with the meters. So 228.58 meters. Now, the next step here is you've got this answer. Oh, what's the other side of this? Oh yeah, okay. So we got to look at the number of significant figures we have. In our original number, we have 750 feet, right? This is 2 significant figures. Our conversion factor has 1, 2, 3, 4 significant figures. Now, there might come a time where you have an exact conversion factor. And if you're told it's exact conversion factor, and say you only had 2 significant figures in it, right? You wouldn't use that as the limiting significant figure, if that makes any sense, because it's exact. In this example, it's not exact. It goes on a little bit. So we've got 2 significant figures in our original measurement. So we're going to flip this over. And we're going to write round the answer to 2 significant figures, right? That's rule number 2. Rule number 2 is the one for, well, rule number 2 is up here. Whole number without a decimal point, right? And based on the rules of multiplication and division, we use the 2 decimal points or 2 significant figures. So we have a final answer of, what did I say it was? 228.58. So we're going to round this to 230. The units are meters. Make sure I'm doing everything correctly here.
I have 2 questions.
Yep.
So for the sig figs, what about the 1 meter? That's just 1 sig fig. You wouldn't count that
Oh, I see what you're saying.
round?
This is, these are just saying equivalents. Yeah, this is exactly 1.00. So yeah, this is the problem with conversions. You've got to look at the original measurement and then the conversion factor you have to equal that 1 meter. So yeah, this doesn't really play into the significant figures.
Okay, and my second question is the 3.281. Where'd you get the 0.281? Because on the chart it just says 3 feet, And if you do just 3 feet, it'd be a different answer.
Yeah, so this is module 3, unit conversions, where now I really got to redo these packets. The first part of the packet, we were only looking at approximate values. So don't use the approximations anymore. We are taking the precise factors from the table in the back. So now we're using a conversion factor table in the back. So
Okay.
the 1 meter is 3.281 feet, comes from here. There's also 1 foot, well, that's foot to centimeters.
Okay, so on quizzes and tests, how do we know like which table to use then?
You're going to use the exact conversions.
Okay, so
Yeah, so the first part of the packet was just to introduce units and approximations. So from going forward, you want to use conversion factors given to you, exact conversion factors. In fact, test number 3 has this. This is all on 1 page, I think. This is a reference sheet for test number 3. I'll pull this up tomorrow and show you guys, I think.
okay, thanks.
Yeah, because test number 3 has its own reference sheet, which you can just print out and use instead of flipping through your notes. Yeah, so that's another issue. Significant figures with conversions and knowing which the exact, that reminds me, I need to label these exact or not. Well, I've looked at the test questions are pretty straightforward when it comes to sig figs when you have to do calculations. All right, the next one here is the conversion of meters per second to kilometers per hour. So this is relatively straightforward on the length component, but not on the time component. So you have to either figure it out or look it up. And we have down here for speed. Oh, in fact, we were given the speed. Right, we were given 1 kilometer per hour is 0.2778 meters per second. So this takes into account not only the conversion between kilometers and meters, but also the conversion between hours and seconds. So let me just fill this out. So the original measurement, right, 12 meters per second. And the units are meters per second. And the target unit is kilometers per hour. So let me see if I can get this straight this time. All right, and the conversion factor we're going to use, again, is from the first page. So 1 kilometer per hour is 0.2778 meters per second. That's the one we're using. So down here, we've got the original unit or the original measurement here, right? 12 meters per second. And we're going to multiply by the appropriate value. So remember, we want to get rid of meters per second. So meters per second is going to go on the bottom. Right? And kilometers per hour on the top. This is what we want. And now this is an equivalence statement, right? How many kilometers per hour are equal to how many meters per second? And our conversion factor tells us that, 1 kilometer per hour is equal to 0.2778 meters per second. So notice here, we're dividing by a decimal. So we should have a larger number that shows up. Let me, before I put the answer in, I'm not going to put the answer in up here. I'll put it in down here because it's just too much, I don't know, stepwise. So which units cancel, right? The units that cancel are the meters per second. And what units remain in the kilometers per hour. All right, so we're going to cancel these out. Meters per second and the kilometers per hour stay. So notice here the kilometers per hour remain, and we're going to pull them outside. And we've got the unit or the numbers now. We've got 12 times 1, which is 12. And then we've got 0.2778. And this gives us 43.1965, etc. Right. So now we're going to look and we're going to round to two significant figures and make sure we keep the units. So we're going to take and we're going to get 43 kilometers per hour. Yeah, so every time I teach this class, I find a problem with the packet that I want to change. I'm actually not the originator of the packet. I've just kept refining it as more and more people complain. So this is unit conversions, and there's a bunch of, are there any questions about the first three here, which sort of walk you through? Yeah, this sort of walks you through. I think what I'm going to do here is do the first one. Well, let me see. How many practice problems do I have? 1, 2, 3. Oh, we got a bunch of practice in the back. These are to do on your own. Self-practice. Let me know if one of the answers down here doesn't match. I don't know why that's answers. It might be helpful to have a piece of scrap paper to work them out on. I don't know if there's enough space to do all 10 of them. So do these on your own. Well, let's start with, let's go on the back here, unit conversions. This is more practice. So this is the type of stuff we covered in the first part, right? These are the approximations. And approximations are, this is something that you get by having sort of a feel for the order of magnitude of things, right? Like what's the approximate height for an average adult, right? 5 meters, that's like 15 feet. 2 meters is the, the correct approximation. And you can go through these. Paper clip, 30 centimeters versus 3 centimeters. What do you guys think?
3.
3, yeah. Appropriate mass for a large textbook, 1 kilogram or 10 kilograms?
1.
Yeah, 1. So this is like, 2.2 pounds versus a 20-pound textbook. There's a book in the library. Have you ever seen the one book where you walk in like the big reference library and there's like a huge book in the middle of everything and it's opened up, it's on a pedestal. And that's probably a 10 kilogram book. 200 kilometers is closer to which distance? This one's a little trickier, I think.
120.
Yeah, 120, because they're so close. 12-gallon tank, filling that from empty takes about how many liters?
3.
3 liters?
Yeah.
12-gallon tank.
Oh, sorry.
Yeah. I think the other way. So this is again, order of magnitude, thinking the other way. If you're used to converting liters to gallons, or gallons to liters, it's going to be different. So it's approximately a factor of 4. So yeah, 12 divided by 4 gives you 3, but then you got to look and say, oh, wait a minute, I converted the wrong way. 10 feet per story, approximately how high is a 6-story building, right? So you look at that, you're like, okay, it's about, what do you guys think?
20.
Yeah, 20. So it's about 60 feet, right? And it's about 3 feet in a meter. So those are approximations. Now, when you get down to, doing more exact conversions, right? This is what's this comma here? Use conversion factors, not approximations. Express all answers to two significant figures. So in this one, I'm actually telling you to use two significant figures. And notice some of these don't have decimal points, right? So, you could put those in, but the point is convert all to two significant figures, all the answers. So let's walk through what we just learned about conversion factors. The first one is, that's not my conversion factor. We know we have 25 cubic feet, right? This is what we have. We want cubic meters, right? So I'm going to form a fraction here. I want cubic meters, and I want to get rid of cubic feet. We need to find the conversion factor that tells us the equivalence between those, right? So if you go into the back of the conversion factor here, there's some for volume. And we have this conversion factor. 1 cubic foot is 0.02832 cubic meters, right? So we have this conversion. In this case, we're going to write the 1 on the bottom, right? Because that's 1 cubic foot is equal to the 0.02. So let me see if I can fit this in. 0.02832. So those are cubic meters. If we do the calculation here, we wind up with 0.708. I'm not going to carry this out any further. I think that's probably it. And we're going to round to two significant figures. What are our units? Our units are cubic meters, right? Because the cubic feet cancel. So our final answer is 0.71 cubic meters. All right, let's see if I've saved myself enough space for this next one. I'm going to write this one kind of small because I want to show you two ways of doing this. We want to convert 60 miles per hour to meters per second. Right, so based on our conversion formula, our generic formula, we have 60 miles an hour. This is our original measurement, miles per hour. And we want meters per second. And we want to get rid of miles per hour. I'm going to do this down here. I'm going to do this two different ways. So I want to show you well, that didn't work well. This is miles per hour. Okay. Now, the first way up here, we go to the back of our conversion factor. And what do we got? We got miles per hour and meters per second. Okay. I'm going to look at, let me fold this. Now I could find two different conversion factors here. Mile per hour is 0.447 meters per second, right? 1 to 0.4, or 1 meter per second is 2.237 miles per hour, right? So that's why I want to do this both ways so you can see the difference. So let's take the first one. We're going to use the 0.447 meters per second is 1 mile per hour, right? So this is all this is saying is what's equivalent between these two, right? And my equivalent statement is that there's 0.447 meters per second in 1 mile per hour. So in this top scenario, we're just multiplying these two numbers and we get, let's see, 26.82 meters per second, right? Because the miles per hour cancel, we're left with meters per second. And the two significant figures, this is going to be 27 meters per second. That's our answer. Now, the other way to do this, we look at the other conversion factor we have. 1 meter per second is 2.237 miles per hour. Right, so what I want to show you is this fraction is just telling you again, 2.237. Oh, you know what? I had room to write miles per hour here. Now, if I do the math on this, I also get 26.82 meters per second. Now, if you do this on your own in a calculator, you might find that the digits after this start to differ. And that's because this is not an exact conversion factor. It's got obviously some rounding in it. But you can see here, in both cases, right, you get the same answer. Or depending on, again, your calculation, your calculator, how many digits reports, it's going to be pretty close to the same answer. What I'm trying to demonstrate here is this ratio, right? It doesn't matter which set of numbers you use. What matters is that you recognize that they're equivalent and you put them in the right spots, right? 1 mile per hour is 0.447 meters per second, right? So the 0.447 goes with its units. The 1 goes with its units and it cancels the units out. And this is basically the 0.447. If you take 1 divided by this, you get the 2.237. So this fraction here is just showing you these values are equivalent, right? 1 meter per second is equivalent to 2.237 miles per hour, or 1 mile per hour is equivalent to 0.447 meters per second. And you should wind up with the same answer. The next one we'll just do with one conversion factor. 20 meters to feet. Are there any questions so far on the conversions? I'm trying my best not to make a stupid typo when I'm talking. All right, 20 meters. Again, we're going to look in the back. Conversion. Our length. We want, let's put this down. We want feet. We have meters. What are some of the conversions? Well, here we've got 1 meter is 3.281 feet. And we don't have foot to meters. I mean, you can look at this and say 1 foot is 0.305 meters, but let's just use the 1 meter to 3.281 feet. So this is 1. Up here, we've got 3.281 feet. And you can take a step back and you can look at this and think about it. Did I put this in the right? 3.281 feet is the same as 1 meter. Yeah, that makes sense, right? This is why it's good to have sort of an idea approximately how much is in which, right? Now, if I had flipped these accidentally, I would have said 1 foot is equal to 3.281 meters. That's not right. Right, so just do a double check after you put your numbers in. Make sure you put them in the right spot. All right, so here we get, what is this, 65.62. Now, what are the units on this? The units are going to be feet, right, because the meters cancel. So the final answer to two significant figures is 66 feet. All right, finally, we have area here.
Wouldn't the final answer just be to one significant figure?
Oh, no, so, yeah. So that is a good point. Now, you saw that there's no decimal point on this. Up here, I said express all answers to 2 significant figures.
Oh,
Yes,
okay.
if I didn't tell you that in advance, yes, it would be 1 significant figure.
It would have been 70.
Right.
Yeah, okay.
For 1 significant figure, which is based on the number. Okay, the last one here. Do I have, what's my conversion factor? Length, okay. Now, this one is a little different. And I should have left myself a little more room. First of all, the area is just the length times the width, right? And we have a room that's 10 feet by 12 feet. Now notice I do have a decimal point here, right? So I'm working with 2 significant digits in the measurements. And I want to find the area of the room. Now, let's see, there's 2 ways you can do this. We don't have a conversion factor for area, right? So we actually have to go in and convert each of the lengths first. Now I'm going to do this in one shot. I'm going to multiply length and width. So the first thing I do is I have 10 feet. And my conversion for that is going to be, let's see. I'm going to use the meters to foot. 1 meter is 3.281 feet. So I want meters and I have feet. Now notice, I want the area in meters squared. We're going to get that when we multiply meter times meter. But right now I'm just converting the lengths. So what did I say? 3.281 is 1 meter. Right, this is L. I'll just define these arbitrary as length and width. We're going to take this and we're going to multiply it by the width, which is 12 feet. And I'm going to write the conversion factor, the same conversion factor for the width as I did for the length, right? So I've got 1 meter is 3.281 feet. This is my W. All right. So what does this equal? Well, I'm going to take this and I'm going to say, okay, first of all, individually, my units cancel. Feet cancel here. Feet cancel here. And I'm just going to multiply in. I want to show you, I've got 10 times 12, right? This gives me 120 over 3.281 times 3.281. This is basically 3.281 squared, right? And the units I'm left with are meters times meters, right? So this just becomes 120 divided by, it's divided by 3.281 twice, right? So you divide 120 by 3.281, then you divide that answer by 3.281, or just 3.281 squared. What's the number I get? I get here, this is equal to 11.15 meters squared, right? Meter times meter is meter squared. And then I'm going to look, I'm going to say I have 2 significant figures in each of these. I'm going to round this to 2 significant figures. So the area is equal to 11 meters squared. That's the area, right? So notice I didn't have an area conversion, but I could convert each of the lengths from feet to meters. And this gave me my, my area.
Excuse me.
Oh, was there a question?
Yeah, I have a question. I did in a different way and I get the almost the same answer. So my answer was 11.163.
Okay.
So is gonna consider like a mistake or
No, because actually when you round that to two significant figures, and this is one reason to use significant figures. First of all, let me just say sort of or clarify something. All the tests are multiple choice. So if you round a little different, if you were to get like 11.15 and 11.16, one of my answers would be 11, right? One of my answers might be 11.15, trying to catch you on significant figures. And then I'd have some other answers where maybe you multiplied instead of divided, right? And so you'd say, oh, 11.16, that's pretty close to 11.15. But then you'd look and you'd say, oh, wait, two significant figures, I got to round to 11. The answer is 11. So yeah, the 11.16 versus 1.5, that's not a big deal. Did you use a different conversion factor? Or?
Yeah, I use this one. Let me show.
I cannot see your screen because you're, let's see. Is that the, oh, use the centimeter one.
Yeah.
Okay, let's do that. Let's just, I got a new piece of paper here. Number 10, math packet, page 24. Since I really don't think it makes sense to start the next section, let's just redo this one. So now we're going to use the other conversion factor, which is, we got feet and meters. So Victor used this one. 1 foot is 30.5 centimeters, right? This is also equal to 0.305 meters, right? So let's do it that way. We've got 10 feet. Now notice our ratio is still, the units are still the same, right? We want to get rid of feet and get meters, except now we have 0.305 on top and 1 foot on the bottom, right? And this is our length. And then we're going to multiply by, I'm going to use some square brackets here. We've got 12 feet. Same ratio, 0.305 meters over 1 foot, right? Again, let's lump this all together. Where's my calculator? There it is. So I'm going to have 10 times, I'm going to take this stepwise. Oh, this is easy, right? This is just 3.05 meter feet divided by 1 foot, right? This is one of those. And then I've got 12 times 0.305 gives me, this is 3.66 meter feet over 1 foot, right? We can cancel units out just to make things a little cleaner. Cancel out the feet, cancel out the feet. Then we got 3 times 3.05. This gives us 11.163 meters squared, right? Same thing as before. Now I want to round it to significant figures. Area is 11 square meters. So yeah, this is an example of what I was talking about earlier. with the miles per hour and meters per second. These are not necessarily exact conversion factors, the 3.281 and the 305. So you can see that when you multiply them out, you're going to get slightly different answers, which again, depending on the rounding scenario, right? Two significant figures, it doesn't even show up. Yeah, so does that make things clearer to people? Maybe. Okay, any last minute questions before we stop here for now? All right, I'm going to stop the recording.